Hey,
Hey,
guess how much is this house?
I don't know. I definitely can't afford it. Maybe 100 grand?
Wrong.
Hey,
How awesome would it be to build a machine that can correctly guess the price of a house just by looking at it? Today we are not gonna do that, but we will teach a machine to guess it by its features, like how many rooms does it have, or the lot size, number of bathrooms, etc. Fortunately, there's a dataset full of house prices and features. You can find it on Kaggle. So, firstly, the steps of machine learning can be summarized in this diagram. It has 3 steps, as the data exploration, model building, then validation. Each step has its own tricks and hardness. Missing something, for example, data exploration, can really affect the thought model. Firstly, let's view our data. The data consists of input and output variables. Currently, we only have one output variable, the price, and 80 input variables. By viewing the output variable distribution, it is apparent that there are more expensive houses than not. This data distribution is our data, because the average of the prices and the most probable price is not the same. With this output behavior, our algorithm would have less chance to learn good model parameters, therefore the skewness should be reduced. Skewness can be reduced by transforming the output data with logarithm or another transforming method. Skewness can be eliminated by transforming the data to make it look like a normal distribution. Here we tested a log and a power transformation. Both seems a reasonable choice, but their distribution makes it more similar to the normal distribution. By viewing the skewness in the table says that the power transformation has less skewness as the logarithm transformation. Therefore we choose the power transformation. Now we should examine the input data. Usually when we get a dataset for a specific program, there could be issues with it. One issue could be missing values. A machine learning model can't deal with missing values, so we have to fill in those gaps. This problem can be solved by deleting those columns that has missing values. That would be the easiest solution, but could lead to deleting important information. A more sophisticated method could be imputation. Imputed values won't be exactly right in most cases, but helps to build more accurate models. Important to mention that categorical data can be imputed, so missing data there has to be solved in another way. We created a category none and inserted it for the missing values. Another problem could be usage of categorical data. The most used encoding is one-hot encoding. This method takes a column and creates a new column for each string value, and encode each string value in a row with 1 and 0 in the accurate place. So if this was a cat, then it gives a 1 in the cat column and 0 in the dog and pig column. The last important thing in data processing that could help the model perform better is cutting outliers. Outliers are data that is distant from the other data. It can be caused by noise, error, etc. They are usually cut out to reduce the error of the built model. The outliers can be discovered by the multivariate normal distribution. The input should be transformed similarly with the power transformer. Multivariate normal distribution is the generalization of one-dimensional normal distribution to higher dimensions. This is needed because we have a higher dimensional input data. The probability to fit in the multivariate normal distribution of the data point can be calculated. With a threshold, the probability value points that are less probable to fit in the multivariate normal distribution can be cut out. For example, choosing the threshold to be minus 150, then the log probability with less than that will be cut out. So to summarize the data processing, first we split the data into input and output. Then the skewness of the output is reduced. After that we split the input to numerical and categorical data, then handle the missing values with imputation. After that we handle the categorical data with one-hot encoding and transform the numerical data as the output was transformed with power transformer, for example, cut out outliers. Then we merge the numerical and categorical data that gives us the pre-processed inputs.
the next step is finding the appropriate model. There are plenty of different types of models available, but which one to choose? You should already know the goal of the machine learning task. In this case, it is to estimate a real number, so it is a regression problem. Then you should know the data. Here it is labeled, so it is a supervised learning task. Then, using a rule of thumb, start with simple model, like a decision tree, which makes simple splits in the data based on one feature at a time. The more important the feature, the higher it should be in the tree. We first tried it, then moved on to the more powerful gradient boosting regressor, which uses many different decision trees together. This performed much better. We also tried a dense neural net, but we could not reach the gradient-boosted regressor performance. But how should we measure this performance? The evaluation of the model is crucial, and there are many tips and tricks to avoid the pitfalls. We need a metric for the evaluation. In this case, it can be mean absolute error, which is less sensitive to outliers than the mean squared error. After deciding the metrics, we have to split the data into train and test set. With the train dataset, we teach our model, then we validate our model with the test dataset. If we split the data multiple times and train on different parts of the data, we can get a more robust result. This is called cross-validation. This way, close to real performance of the model can be measured. If the model performs poorly on the trained data, then it is underfitting. You can compare the performance by the top of the Kaggle leaderboard as reference. In this case, we should increase the model complexity. For example, use the gradient-boosted regressor instead of the simple decision tree, or add more depth to the tree. This is a hyperparameter, and there are many others like the learning rate. You can try different variations based on the score of the training. Now we can get a very good result, but then if you look at the evaluation score, it is not near as good. The model is overfitting the training set. It doesn't generalize well, it just learned the train set values. More data, model generalization, or early stopping can help. If we are not sure which hyperparameter of the model should be tuned, then a grid search can be our friend. You can train the model using different hyperparameters. This is costly, but there is a good chance that you can further improve your model. The final result can be saved, uploaded to Kaggle Challenge, or you can use the model or data on a real-life example. The performance of the model can be further improved if we include the features of the test data during the data preparation, so the multivariate normal distribution and outlier detection can do a better job. In practice, it means that we have to retrain our model every time we see a new measurement, or at least time to time. Some real-time applications does not allow this. Let's see our real-life example. The data contains house prices and features from Ames, USA. We looked for some online data and found selling houses in Ames on Craigslist. We used a simple web scraping to get the data. There were much less features than in the dataset, so we retrained our model using only those features. I think the result is pretty good, but I'll let you decide. It shows correlation with the proposed prices, and the ranges are about the same. The houses were not sold yet, so the price is actually not the ground truth. We used much less features in the real-life example, and the two dataset distribution is close but not the same, meaning not from the same source. We could include a part of the real-life examples in the train data would help. Also, collecting more real-life data would increase the performance. Thank you for watching. See you next week with another machine learning project.